just to do my little spiel about the Institute. For those of you who are new, this is our homepage, and our mission at the Institute is to be the translators of great science into coaching practice. In fact, when you become a member, you can actually watch Lisa's talk at our last conference when we were actually all together in one place, which was wonderful. But we have many, many other resources, webinars, research doses where we translate research papers, and our coaching reports and interviews and all kinds of things. So we welcome all of you who are maybe new to us to join us on our journey. All of the donations that you make go into coaching research and translation of science into coaching practices. With that said, it's my great pleasure to introduce Lisa. I like to say Lisa's a fellow Canadian. I grew up, in fact, my family's from Waterloo, where my mother's family, so I'm very proud of Lisa coming from my my roots and being in Boston. And but most importantly, she is, in the top handful of scientists that are informing coaching practice today. It's a small group, and Lisa's work is just friggin' amazing. I mean, it's mind-blowing, and I'm so proud that you're here and that you're doing this great work, and you're unafraid of stepping outside the conventions and the way things are explained and described and put into frameworks. With that, I'm not going to go any further because you've got plenty of other accolades that people can read about, but we're going to get into the talk. We'll have about a half hour for questions, and take us on your journey, Lisa. We're so looking forward to it.
Thank you. Thank you so much, Margaret. And thank you again for inviting me to join you and to talk with you about my work. And I really appreciate the very, very warm introduction from one Canadian to another. So hi, everybody from Boston, Massachusetts. It's a nice, fall gray day in Boston. Luckily, I've been really looking forward to talking to you, and I'm going to give the talk pretty much, it's in some ways pretty much similar in certain ways to the talk that I gave last year, very much based on my first book, How Emotions Are Made, The Secret Life of the Brain. But there are some themes in that book that I excavated and worked into a new book of little essays about the brain and what those little nuggets of neuroscience mean for being human. And so the book is called 7.5 Lessons About the Brain. It's a book that's, wasn't written to be technical, although there is an appendix and there are a set of web notes that give more technical information. Really, the essays, invite you to think about what it means to be human and exactly what kind of human you would like to be based on these little nuggets of neuroscience. And so I'm going to share some of that with you today as well. And I'll try to flag that for you. So right now I'm going to I'm going to share my screen, and I'm going to launch the talk. And I think what I'm going to do is periodically stop and allow for questions as we go along, because I just think that will be, it will make things flow, I think, a little more smoothly for people. And so the focus of today's talk is really about the nature of emotion and the way in which you are an architect of your own emotional life, and to some extent, the ways in which you can translate this for your clients as in your coaching work. But I'm also going to be touching on, as I said, some more general principles of brain function that really undergird this perspective on emotion and really can be applied to understanding other phenomena as well. So in the history of science, there are lots of examples of fictions, things that we used to believe were true and that we know are no longer true. For example, we used to believe that the sun revolved around the Earth. And we used to believe that the Earth was flat. And scientists and observers developed new ways of observing the world in order to dislodge those fictions and replace them with a better, more valid understanding of how the world works. And something similar is true for the nature of emotion. So it turns out that several of our most cherished beliefs about emotion turn out to be fictions. And so in the next 50 minutes or so, plus questions, so maybe 90 minutes, we're going to have a go at squashing 3 of these fictions. And what I'm going to try to do is leave you with some insights, several of which speak to the issue of the ways in which mental health and physical health are related to each other, and actually maybe 2 sides of exactly the same coin. And this is very relevant, obviously, for the pandemic and the moment that we find ourselves living in. In particular, what you will notice is nearer to the end of the talk, I'm going to make a large emphasis on the way in which the metabolics that underlie brain function are actually linked in a very intimate way to the thoughts and feelings and actions that make up your everyday life. That the metabolics of what's happening in your body and in your brain have a lot to do with how you are situated in the world. That is how you, your way of being in the world. And I'm not going to reduce everything to metabolism, but I am going to emphasize this because I think it's a piece of the puzzle that is often overlooked. I should also mention that everything that I'm going to discuss with you today is based on mountains and mountains of peer-reviewed research, but I'm not going to be presenting much of that research to you today. Instead, I'm going to be presenting the high-level summaries, and the research you can find referenced in the appendix or the endnotes of how emotions are made, along with there's a website with web notes that have hundreds of references to scientific articles. The same is true for 7.5 Lessons About the Brain, my new book. And my website, my popular website, lisafeldmanbarrett.com, also has a lot of articles and lectures referring to scientific references. And then, of course, there's my actual academic website, which has our 240 plus scientific papers that are online and freely available to you. So the first fiction that we're going to address today is the idea that emotions are displayed on the face with expressions that we recognize. So we're all supposed to smile when we're happy and frown when we're sad and scowl when we're angry. And everyone around the world is supposed to be able to recognize smiles, frowns, and scowls as expressions of emotion. Hence this notion that we can read emotion in other people. I'm going to summarize approximately 1,000 published papers with 2 slides now, and with one example, or with a couple of examples, I guess, that are related to each other. So when we look at this person's face, people usually see this person as sad or tired or grieving. Actually, this is my daughter Sophia from a couple of years ago when she was experiencing only what I can describe really as a profound sense of pleasure. She is on her 2nd chocolate drink at the chocolate museum in Cologne, Germany. And this little sweetie is also experiencing a profound sense of pleasure. And what you can see by looking at their faces is that the facial configurations, the configurations of muscle movements are completely different. And so the lesson here is that people move their faces in different ways during instances of the same emotion category. For example, research shows that when people are angry, and we're talking about people in largely Western cultures, but large urban settings, they scowl about 30% of the time, which means that 70% of the time they're doing something else with their face. Now, 30% of the time is above chance, and that gets you a publication in a journal. But 70% of the time, people are doing something else that's meaningful with their face that expresses anger. And so a scowl, we would say, has low reliability for indicating or expressing anger. So it's one expression of anger amongst many expressions of anger. And I think that's one punchline to take away from this, right? Is that that there's variability in how your clients express the instances of a single emotion category. Now, if we look at this little guy's eyebrow region, we can see that he's arching his eyebrows in a way that people believe is the classic sort of universal expression of anger. Ditto for this guy's face. People usually see him as very angry, or really furious. But actually, this is a photograph of Jim Webb in 2006 when he won the senatorial race in Virginia and returned the Senate to Democratic control with his victory. Without context, we see his face as communicating anger because, in fact, this is the face that often symbolizes anger in Western cultures. And so the message here is not only that people move their faces in different ways during instances of the same emotion category, but also they move their faces in the same way during instances of different emotion categories. Or said differently, a scowl not only has low reliability for expressing anger, it's also not specific to expressing anger. People scowl when they're confused. They scowl when you tell them a bad joke. They scowl when they're concentrating really hard on what you're saying. They scowl when they have gas. They scowl for all sorts of reasons. The point here is people are not moving their faces randomly, but the way that they're expressing with their facial movements and their bodily postures and so on really depends on the situation that they're in. So the punchline is that what the data show again and again and again is that when it comes to emotion, a face does not speak for itself. When you see emotion in another person, like in your client's face, your brain is guessing what that facial movement means. These guesses are occurring automatically with very little effort or awareness on your part. And even people who believe that they read others well are guessing. Their brains are guessing. So you may have a lot of confidence in your guesses, but they are nonetheless still guesses. And you are making a guess about, what your client's facial movements mean, depending on your own past experiences, your experiences with this particular client, and also the context that's surrounding you. And ditto for your client. When your client is, recognizing or reading emotion in other people, he or she is really guessing, and they're guessing using that same collection of information from the past and information about the immediate context and so on. So when it comes to facial expressions of emotion, variation is the norm. And this is true of any signal that we can measure about emotion. It doesn't matter whether we're measuring signals from the body or signals from bodily movements, or whether we're measuring the brain, your brain is creating expressions that are tailored to the specific situation that you're in. And this is also true for your clients. And your brain is also creating perceptions of emotion out of other people's facial movements, very specifically tailored to the situation that they're occurring in. So what's up with these expressions? Where did they come from? Well, it turns out that these were not discovered by observing people express emotion in various situations in real life. These expressions were stipulated by a handful of scientists and then adopted as universal truth. And then people built a whole science of emotion around them. So really, they are stereotypes. They are Western stereotypes of emotional expressions. And I will say that the majority of research that is done, um, that's published actually on facial expressions, um, actually uses these posed faces or something like them, meaning that we have a science largely of stereotypes. And I say that really gingerly because, increasingly that's changing. Scientists are increasingly actually attempting to measure real world variation in facial movements and understand the links to emotion. And that's a really good thing. But currently, as things stand, um, we're really using a science of stereotypes. That's really what we have, largely in the published literature. And I should also point out that these stereotypes don't hold the minute that you leave large urban settings. So my lab has been to Namibia, and we've been to Tanzania, and we've studied hunter-gatherer, um, individuals who live in hunting gathering cultures. And I can tell you that these stereotypes don't hold in those cultures, not even remotely. And so this is a really, really important, I think, lesson to keep us curious and humble when we're interacting with people and attempting to infer what they might be thinking and feeling.
Lisa, I might want to jump in here because there have been maybe 6 or 7 questions about how you would view Paul Ekman's work.
Sure, I'm happy to do that now. I was just getting to the end of this segment, but I'm totally happy to answer those questions now.
Yeah, so the main questions, how do you view these conclusions vis-a-vis his work? Does this debunk his work? Or, what would you?
Yeah, I don't really think debunk is the right way to think about it. So I'll tell you that I, along with 4 other senior scientists, all coming from various different perspectives in the science of emotion. Basically, we didn't agree with each other before we started this work, undertook a project for 2.5 years. This was before COVID, but we were meeting once a week for a couple of hours on Zoom because we were in different parts of the world, evaluating the research. Certainly Dr. Ekman's research, but also other research that had been published on emotion, emotional expressions and emotion perception. And I don't think it's, I try really hard not to use the word debunk because I don't, I think that Dr. Ekman's work discovered something important. It's just not what he thinks he discovered, okay? There are certain elements to the experimental method that Dr. Ekman used that, in effect, teach people what those faces are supposed to mean during the experiment. And you can view that as bias if you choose, but I choose to view it as instructive, that that words, pairing a word with a face is a really powerful thing. It leads you to, it influences how you see emotion in the face. So basically, most of the research, actually all of the research, almost all of the research that Paul did uses one of 2 methods. You show a posed face with no context at all, and you give a set of words, and you ask people to choose the word that matches the face. So anger, sad, fear, disgust. Or you tell a little narrative story, like Bobby is sad, Bobby's dog died. And then you show 2 faces that are posed, and you ask, how would Bobby look if he was expressing sadness? And then, you might have like a frown and a smile. And through a series of studies, some of which were published by, there's a really good summary of some of the issues with these methods called forced choice methods, that was published by Jim Russell in 1993 in Psychological Bulletin, or 94. Anyways, 93 or 94, I'd have to check. As well as from our lab, we actually demonstrated that when you take this method, you can plop any set of faces, actually any set of vocalizations that you just make up, and you can teach people to match the words with the vocalizations or the faces. In this case, I'm talking about vocalization. So we just made up vocalizations and we attached them to emotion concepts that don't exist in English, that don't exist in the languages that we were testing, and that have never been claimed to be universal by anybody. And we just gave them to subjects in various cultures, including the Hadza hunter-gatherers of Tanzania, and 5 of the 6 categories came out looking universal. So what this demonstrates to us is that words are really, really powerful ways that influence how we make sense of physical signals that can take on many different meanings. Should I pick up now, do you think, Margaret, or is there another question?
That's it. There were a lot of people asking about Paul Ekman.
Yeah, I would suggest that anybody who's really interested in this can go to my academic website. There's a paper which I believe I've referenced in this talk. It was published in a journal called Psychological Science for the Public Interest, and it is this review that I worked on with these 4 other senior scientists, and we worked for almost 3 years, actually reviewing more than 1,000 papers. And the point to make here is that we all came in with different hypotheses. Some were, really strong believers in universal expressions of emotion, so very similar to Paul Ekman's work, and some were not. And the bottom line is that we all came to consensus over what the data show. It was actually a great exercise in the value of scientific inquiry from my perspective. And I think that will explain, how we understand Dr. Ekman's work, as well as how we put it into the context of the existing, body of literature. There's also a paper on my website where Maria Gendron, a former student of mine, is the first author, and that reviews, I think it was published in 2018 in Current Directions in Psychological Science, and it reviews not only the 4 data sets that Dr. Ekman published from Papua New Guinea, but also the newer studies, which in remote cultures, I think up to maybe 12 now, some of which are ours, some of which come from other labs, which show that these expressions are not universal. It shows pretty clearly and convincingly that these expressions are not universal under any definition of universality. So let me just launch this again. And so the message here is that when you see emotion in another person, your brain is guessing what the facial movements mean. And these guesses occur automatically and effortlessly, as I said. And basically, you're not reading expressions the way you would read words on a page. Your brain is using your past to make really effective guesses in the present. And to some extent, what you're trying to train your clients to do is to make the correct guesses in particular situations. And these guesses are how the raise of an eyebrow or the curl of a lip or the tilt of a head or any single physical feature takes on different emotional meanings in different contexts. And so the emotions that you seem to detect in other people actually are coming in part from inside your own head. And in fact, this is true of everything you see and hear and smell and taste and feel. Everything you experience in the world is some combination of what's inside your own head and what's actually out there in the world. And so it's important to remember that when you hear other people talking about emotional intelligence, really what you should be translating that into is to building a repertoire that will allow you to flexibly make sense of what facial movements mean in the context of a whole range of other contextual cues. And that when you are learning, when you interact with one person over time, in part what you're learning is what their facial movements mean in their own repertoires. So emotional intelligence is not learning to recognize a scowl in someone's face and assume that it's anger. It's understanding how to flexibly learn what a vocabulary or a repertoire of facial movements mean in particular contexts for particular people. So it's actually a much harder task than the initial work on emotional intelligence led us to believe. This would be the point where I would normally ask if there were any questions. So Margaret, are there any other questions that might be useful to answer before I hop into the next fiction?
You know, we've got like more than 30, so we're not sure. We will have plenty of time to talk. I think you should keep going.
Okay.
And then I'm going to group these together so that we'll.
Okay. And definitely feel free to just feel free to stop me. I mean, I'm going to probably try to stop at several places before I get to the end of this next segment, because I've added some new material based on our conversation before today's session. So I'll try to be mindful of stopping, but definitely stop me if there's something that's useful to talk about.
Yeah. Maybe one thing, Lisa, which is where do mirror neurons fit in to this story? Because
wow. Okay. Yeah. Okay.
Allowing us to tune in.
Yeah. So I guess the thing to say here is that mirror neurons, or first of all, the neurons that are referred to as mirror neurons are not special in any way that anyone has ever been able to discover. And what they're doing seems to be what neurons do, just more generally. So there are a set of neurons that are sitting in the premotor cortex, the part of your cerebral cortex called premotor cortex, that are supposed to be specific for helping you to empathize and to read other people's minds and infer their emotions and so on. And I guess what I would say is this, that as you'll see in the next series of slides, part of what your brain is structured and designed to do is to continually make guesses about what's going on in the world and what's going on inside your own body based on past experience, which sounds, I know, very preposterous, but as you'll see, it's counterintuitive, but it's not preposterous from a neuroscience standpoint. And so I guess the best thing I can say right now is keep that in mind. Let's get through this next section, and then we can return to the question of mirror neurons, because I think it will make more sense once you've heard what I have to say. So the second fiction really is that there are dedicated circuits for emotion in your brain. We often experience emotions as happening to us, taking over our behavior and making us do or say things that are ill-advised. And these experiences lead us to believe that the brain is a battleground, that emotions live in one part of the brain, rationality lives in another, and that they're in a constant battle for your behavior, to control your behavior. And so that really what you want to have is your thoughts, your rational thoughts, regulating your emotions. And when this doesn't happen, we usually assume that the person is either immoral or mentally challenged, mentally ill. But using our experience, our intuitive experience, as a guide to what's actually happening in the brain is almost always ill-advised. Our ideas about where the idea that the brain is a battleground between emotion and cognition is really comes from ancient Greece. It's a kind of a morality story that comes from ancient Greece. And it really has nothing to do with brain structure or brain evolution. And as you'll see, we don't have a lizard brain. That lizard brain is not hijacking the more rational parts of the brain. That is one of the most successful and most cherished fictions in what it means to be human in the Western world. And it doesn't match the biology at all. So there's so much evidence that I could present to you today to demonstrate this, but we only have 90 minutes, so I'm only going to present one example right here, and I'm going to start with the focus in on a brain region called the amygdala. So here what you're seeing is a coronal slice of the brain. If I were to take a knife and slice this way and pop the front off my brain, clear off all the blood, what you would see, what you'd be looking at is basically what you're looking at here. The amygdala on one side of the brain is labeled. There's another matching structure on the other side. And this region's kind of like the rock star of the brain. It's supposed to be important for emotion and specifically for fear. And I say it's the rock star because this is the brain region that shows up in a lot of news stories. It shows up in a lot of documentaries and scientific TV shows like on Netflix. It's really thought to house the circuitry for fear across all mammals and maybe all vertebrates on the earth. And so in my lab, we tested these claims. We statistically summarized hundreds of studies where people were experiencing emotion while they were having their brain scanned. And so what I'm going to show you here are the proportion of studies that show an increase in amygdala activity during various types of emotion that are being experienced. And along here, the horizontal axis are the proportion of studies which show an increase in amygdala activity. Now, if you look across studies, what you can see is that almost 30% of the studies where people are experiencing fear show an increase in amygdala activity. Now, that is significantly better than chance, but what it means is that about 70% of the studies don't show this. And that's a lot of studies. That's more studies than what you would expect just based on random error, which means that the amygdala might be important for certain instances of fear, but it's not important for all instances of fear. And even more telling is the fact that amygdala activity is not specific to fear. It was observed in instances of every emotion category that were ever studied. And in fact, the amygdala often shows an increase in activity even in studies that have nothing to do with emotion. For example, if I just show you novel faces or novel images that you've never seen before, and the faces maybe are completely neutral, or the scenes are completely neutral, like just, images of mountains and trees and so on, rivers and so on, you would see a tremendous amygdala activity. And the reason why is that, the amygdala has a number of jobs, but if we were to summarize them, we would say its basic function is to alert the rest of the brain when there is something novel or ambiguous or potentially potentially relevant to your well-being or your life. And your brain has to learn about the situation better in order to predict next time what is needed to keep you alive and well. So in a few moments, I'll talk to you a little bit about how the brain, its main mode of functioning is prediction. And so the amygdala you can think about as sort of like a sentinel, for lack of a better phrase, to indicate to the rest of the brain or signal to the rest of the brain, something is important that I need to learn here, so that I can do a better job of predicting what's going to happen next time. And just to make the point that this point that I'm making about the amygdala not being the home of fear, I want to show you that this is not just a trick of brain imaging. Here what we have are structural brain scans of monozygotic twins, so twins that share 100% of their genetic material. And here what I'm showing you are horizontal slices of the brain. So if we were to slice the brain this way and pop the top off and look down, that's what you'd be seeing. And what I've done is I've chosen images where the amygdala used to be in these twins is now circled with color. So these women, when they were 12 years old, developed a disease that calcified their amygdalas and made them basically destroyed the amygdala, the neurons in the amygdala. And what's interesting about this is that this sister, BG, has difficulty perceiving fear and experiencing fear under most circumstances, not all. She can experience fear in certain circumstances, but her sister, AM, is completely normal when it comes to the experience of fear and the perception of fear. So this is an illustration of what biologists call degeneracy, which means that the brain has many, many ways of producing the same function, in this case, making an instance of fear. So the point here is that in your brain, you don't have one circuit for fear, you don't have 3 circuits for fear, you don't have 5 circuits for fear. You have circuitry that allows your brain to make fear in a highly flexible, situated way. Sometimes in fear, you scream. Sometimes in fear, you freeze. Sometimes in fear, you laugh in the face of fear. Sometimes in fear, your heart rate goes up. Sometimes it goes down, and so on and so forth. Your brain is basically wired with a bunch of ingredients that it can use to make different instances of fear. And the instances of fear that it makes with these ingredients, I should say it differently, the ingredients that it uses are the same ingredients that it uses to make instances of anger and instances of awe and instances of thought and instances of decision making and so on and so forth. And so what does that mean about this sort of, story that we tell about how we have circuits in the brain that we inherited from reptiles that contain the recipes for instincts, which is laid on top of that evolved the circuitry for emotion, which is called the limbic system, including the amygdala, where limbic means border, that is new regions that border the reptilian brain, on top of which evolved the cerebral cortex for rationality. What do we make of this? This idea that we have an inner beast, the reptilian or limbic parts of the brain, which are in constant conflict with the cortex. And the answer is, what we make of it is that it's a myth. It's a story that comes from ancient Greece about moral responsibility, Plato's 2 horses and the charioteer, where one horse are the instincts, one horse is the emotions, and the charioteer is rationality. And Plato was telling a story about what it means to be a moral person in terms of the struggle between, your inner beast and your rational self. And in the 20th century, scientists basically took this story and tattooed it onto the brain. But since the 1970s, it's been known by peering deep into the cells in the brain, deep into their molecular structure, it's been known that this story doesn't really hold water. This is not really how the brain evolved. This is not really how the brain functions. It's not how the brain is structured. And if this is something that interests you, I would suggest that you have a look at my new book, 7.5 Lessons About the Brain, particularly the first half lesson and lessons 1 and 2, where I describe what we do know actually about brain evolution and how the brain is structured and in how it functions more more specifically. What about System 1 and System 2, popularized in the bestseller Thinking Fast and Slow by Danny Kahneman, where System 1 refers to your fast automatic responses like losing your cool in a meeting, and System 2 refers to more deliberate responses like rationally weighing pros and cons in a business decision. Don't Systems 1 and 2 mean that emotion and reason are in separate parts of the brain and they're really battling each other? Well, that is what, Danny Kahneman would have meant if he thought that these systems were actually akin to brain systems. But that's actually not what he wrote. He wrote that this is a metaphor, just like Plato's horses and the charioteer is a metaphor. Systems 1 and Systems 2 are a metaphor that capture our experience of how we make decisions. But they do not map directly onto brain anatomy. And they were never meant to in Danny's book. And I believe he says this really, I know he says this really explicitly in his book. But I think it's on page 11 or page 13 or something. I think what this is supposed to indicate to us is that sometimes the brain is in a mode where it's engaging in automatic processing pretty fluently without any sense of effort on your part. And sometimes we engage in behaviors that feel a little more deliberative and feel a little bit more effortful. And so you can think about these as two modes that the brain is in, not two systems that are battling each other in the brain. So sometimes your brain is basically on autopilot, and other times it's not. And what I'm going to show you in a couple of minutes is another way to think about what this might look like in how the brain actually works. But just to, before we take a break, I just want to sum up for you that the punchline here is that emotions are complex constructions in your brain, in your whole brain. They are not simple circuits. You don't have mythical emotion circuits buried deep inside some animalistic part of your brain. The exact same brain ingredients that go into making an emotional event also make the events that we experience as thinking or decision making or rationality and so on. And reason does not rule emotion. They don't live in separate parts of the brain. And so what does this mean for the workplace? It means that people like to think that they can set aside emotion and make purely rational decisions, which means the absence of emotion. But every decision, as you will see close to the end of this talk, every decision that you ever make and that your clients ever make is influenced by how you feel or how they feel. The wiring of your brain guarantees it, right? You never make a decision that is free from feeling, and neither do your clients. Sometimes the feeling is in the background and sometimes it's in the foreground, but as you'll see, it's actually biologically impossible to ever do anything in the absence of feeling unless you have a non-neurotypical brain. So emotions are not built into your brain from birth. They are built by your brain as you need them. Sometimes they're built in a way that leads to effective behavior. Sometimes they're not. And so if you want to change your emotional behavior, you don't wait until the whole episode plays out and then try to counter it after the fact. Instead, like a good chef, you might try to learn the recipes that your brain is using, and then you can tinker with the recipes and change the outcomes. And that's really what you're doing with your clients when you're trying to teach them how to respond differently with different emotions, or to play out those emotions differently in their working lives. And so I will stop there and see if there are any questions before I I jump into, I've told you how the brain doesn't work, but I now want to talk a little bit about how it does work. But before I do, let me see if there are any questions. Margaret.
Thanks, Lisa. I think this might be a good time to address two, and I'll just put them out there. You can choose to go ahead or not. One is, so the question, so we've all learned about amygdala hijacks, right? Okay, so this is one of the myths you're busting. And it's still pretty common in the lexicon out there. So people are wondering, again, maybe you could just really clarify what is the role of the amygdala, and is it hijacked? And then the second point right now, there's several people have asked about how you view polyvagal theory. In particular, that when our vagal tone is good and we're calm, what happens in that situation with our emotions, and then what happens when we're in fight, freeze, or flight.
Yeah, so the first question is easier, I think, a little bit to answer than the second question, but basically the amygdala is not one thing. It's actually a collection of nuclei, little clumps of cells that do somewhat different things. But if you were to sum up and generalize what the amygdala is doing, it's alerting the brain, the rest of the brain, when something needs to be learned. So as we'll see in a moment, the way that the brain works is by prediction. Your brain is not reacting to things around you in the world. Your brain's actually predicting everything that's going on. So for example, right now, it seems to you like you're just listening to what I'm saying and reacting to my words, but actually your brain, based on a deep knowledge of English, is predicting every single word that comes out of my mouth. And hopefully you predicted the word mouth. And if you didn't, then I'll just say that if I had said every single word that comes out of my nose or my ear or some other orifice of my body, that would be pretty surprising, because your brain is actually predicting all the time. And sometimes it predicts well and sometimes it doesn't. And when it doesn't, the brain marshals its resources to learn what's going on in the situation and in your own body in order to predict better the next time. So in a sense, your amygdala is marking events that are salient and important so that they have to be learned. That is, you have to take in new information that you didn't know, or that you were unable to predict. That's really what the amygdala seems to be doing. There are physical consequences to learning, including, we have certain types of chemicals in our brain, one of which is norepinephrine, a chemical called norepinephrine, which is secreted increases in secretion whenever we have to learn something new, pay attention to something and learn something new. That increase in norepinephrine also goes along with an increase in sympathetic nervous system tone, which leads us to feel jittery and aroused, oftentimes in an unpleasant way. So the amygdala is not the home of fear, it's not the home of anxiety, but it is acting like a sentinel or a cue to other parts of the brain, including the nuclei that secrete norepinephrine. To put the brain into a condition where it is more easily learning or encoding new information. Regardless of whether that information is related to emotion or not. It doesn't matter. I could show you something completely neutral. If it's novel, it will evoke an amygdala response. It was not, because if it's novel, you weren't able to predict it, probably. Regarding vagal tone, polyvagal theory is a very complex theory that has many, many parts to it. It's not original to polyvagal theory, the idea that vagal tone, that is the variability in firing of the vagus nerve in your body is related to feeling good and calm. So in general, the evidence suggests pretty clearly for many, many years now that your sympathetic nervous system and your parasympathetic nervous system, that is two branches of your autonomic nervous system, which is in the peripheral nervous system, that is not not part of your brain and not part of your spinal cord. These are the peripheral, the autonomic nervous system, meaning sympathetic on one side and parasympathetic on the other, jointly innervate most of the organs in your body. And sometimes people talk about, you know, the sympathetic nervous system as fight or flight, and the parasympathetic as tend and befriend, or rest and digest, really cute little phrases, all of which are gross oversimplifications. The vagus nerve is in your body is strongly related to parasympathetic control of the viscera of your heart and lungs and so on. But it's not only about calmness and rest. That is, your heart rate can increase and your blood pressure can change by increasing sympathetic nervous system activity, or by withdrawing parasympathetic nervous system activity. And the two don't always work in opposition to each other. So your sympathetic nervous system can increase activity, and so can your parasympathetic increase in activity, and there will be no change in heart rate at all, because the parasympathetic is increasing, which tries to slow the heart, and the sympathetic tries to speed the heart. And if they're equal, you see no change in the heart, despite the fact that there's a huge increase in both. Sometimes, you know, sympathetic goes up and parasympathetic goes down, and then what you have is a big increase in heart rate, because parasympathetic withdrawal just on its own will increase your heart rate, and sympathetic innervation of the heart will increase the heart rate. So why am I going into all this detail? Because variability in vagal tone means that your vagus nerve is very, very flexible. It's the signaling in it is changing rapidly because parasympathetic nervous system activity is highly variable, and that is a good thing. For example, the one way that you can get a handle on your autonomic nervous system, which largely speaking is not easily controllable, that's why it's called autonomic, that's what it means, that it's not really in your conscious control. The one way to get a hold of it is to breathe deeply, and to breathe slowly in a diaphragmatic way, so that your stomach is expanding, not your chest. You're trying to deep breathe in a slow paced way. And when you do this, it actually marshals parasympathetic activity, which calms down, which calms you down, because it's actually like reducing your heart rate and you know, so breathing and the parasympathetic side of the house, so to speak, I guess, are deeply entwined. So one way to calm yourself down is to breathe deeply, because it marshals parasympathetic control of your organs. And so in that sense, polyvagal theory is correct. But there are many other parts of polyvagal theory that are currently debated, I would say. Other questions, or should I continue? Margaret?
I'm sorry, I had muted myself. No, keep going.
Okay. So emotions that seem to happen to you, that is they're, it seems like we're having our brains hijacked by our amygdalas, are actually made by you, or more precisely, they're made by your brain in the following way. Physical changes in your body are happening all the time, but they have no inherent meaning emotionally. So your brain is controlling your body, and physical changes in your body are occurring all the time. Your brain is attempting to make those changes meaningful by linking them to the things that are going on in the world. So basically, your brain is creating emotions, and really every other mental event you ever experience, when it explains your internal sensations in terms of what is going on around you in the outside world. So your emotions are not reactions to what situations, what's happening in situations. In a sense, your emotions are what situations mean. They are an understanding of what the physical changes in your body mean in a particular situation. So in this way, this is why, an ache in your gut can be hunger at dinner time, and the same ache in your gut can be anxiety if you're in a doctor's office waiting for a test, or it can be a feeling that somebody is guilty when you're in a courtroom listening to a defendant. It's exactly the same ache in your gut, but your brain has to somehow make meaning out of what that ache means in a given situation. And so how does your brain do it? Well, this is a highly simplified, what I'm going to give you now is a highly simplified answer. But it is the answer that we have that's based on our best available evidence from a number of different scientific disciplines. You can think about your brain as being entombed in a dark, silent box called your skull. And it learns what's going on in the world only indirectly from scraps of information from your eyes and ears and other sense organs. Now, these scraps of information are the outcomes of something that has happened in the world, right? So when you hear a bang, that bang could be someone slamming a door, or somebody dropping a box, or somebody car has backfired, or it could be a crack of thunder. If you live in the United States, it could be a gunshot. Your brain receives the effects of something that happened in the world, and it has to figure out what caused these effects so that it knows what to do next to keep you alive and well. But the tricky bit, as I said, is that the sensory information is incomplete. Any given flash of light or change in air pressure or any sensory change can have many, many, many different causes. In the same way, your brain also has to make sense of sensory signals from your body. So, the example I just gave you about a change in, a feeling of aching in your gut, or, we could talk about, if there's time, aches in your chest and the way that your brain makes sense of those. But the point is that in both cases, your brain is receiving sense data, which are the outcomes of some set of causes. And your brain has to guess at what the causes are. And this is what scientists and philosophers call a reverse inference problem. So how does the brain solve this reverse inference problem that's happening at every waking moment of your life? And the answer is by using past experience. So in effect, what your brain is doing is it's solving the reverse inference problem by asking itself, figuratively speaking, the last time I was in this situation where my body was in this condition, what did I do next? What did I see next? What did I hear next? What did I feel next? And it begins to prepare those representations in advance, as it's waiting for the next volley of sense data to come in. Now, in psychology, a group of things that are similar to each other is called a category. So when your brain asks, what is this pattern of sense data right now, the sights and sounds and smells and what's going on in my own body, what is this pattern similar to? It's constructing a category. Now, a category is not something that you have stored in your head. It's not a tidbit of knowledge that you can pull up whenever you need it, like a file from a file drawer. A category is something that your brain makes. It's a guess about what to do next with to deal with the state of your body in relation to what is going on around you in the world. So when your brain uses past experiences of anger to make sense of the sense data in the current moment, your brain is constructing an instance of anger in a very, very specific way that's tailored to the specific situation that you're in. And ditto for every other emotion, instance of emotion that your brain is making. So I want to just go over really briefly what a category is and how it works, because I think there are some really deep misconceptions. Again, these are intuitive ideas that scientists have shown to be, scientists have shown that categories are not what we think they are, really, and that concepts, which I should have said, a concept is a mental representation of a category. So really what your brain is making are conceptual categories. And so I just want to go through this a little bit. So a category is a group of things that are similar in some way. Like here we have a category of cats. You know, cats are similar in various ways. They have whiskers, they have pointy ears, they purr. And this list of features is what people used to think a cat was. That, you know, does it have whiskers? Check. Does it have pointy ears? Check. Does it have fur? Check. Yep, it's a, you know, it's a, or does it have purr? Yes, it does. So it's a cat. This is what people thought the concept was for the category, that you stored a list of features in your head and you retrieved it or recollected it whenever you need it. But the thing is that there's plenty of variation in this category. Some cats are large and other cats are small. Cats vary in their eye color and in their fur color and in their fur thickness and whether they even have fur at all. So the simple list idea doesn't really work as a concept for a cat. In the real world, your brain represents concepts that are not defined by mere physical similarities. When your brain asks what is similar to the present moment, it's not asking what looks the same as the present moment, what sounds the same. It's asking really about functional similarities. So when I ask you to think of a cat and you're in a pet store, your brain is going to construct the concept of a cat that would make a good pet. And if I ask you to think of a cat in a zoo, your brain is going to construct a very different example of a cat. It's going to construct a different concept of a cat. And after you've seen a mouse in your kitchen, your brain might conjure a cat, well, not build a cat, but maybe a cat who's a really good mouser. And when we're thinking functionally, we might even be thinking metaphorically, like, you know, a cool cat, like the dude from The Big Lebowski. Now, all of these instances of cats here are physically different, but they share a similar function. So the concept of cat really changes with the situation, because the function, how you manifest the function of a cat, changes from situation to situation. You can do the same thing with any concrete category, like a bird, right? The bird that comes to mind, the concept that your brain makes for a bird is different if you're hungry and you want to eat, or if you're looking for a pet, or if you're in a park. So a cat or a bird or what have you is a conceptual category or an abstract category. The instances might look physically different, They might sound different, but in a specific situation, they all share a function. And that is how your brain tailor makes conceptual categories as you need them. And so when you're faced with a reverse inference problem like this one, what are you seeing here? You see a cat, most likely. Why? Because your brain just made a concept for cats. I just ensured that by giving you those examples. But there is no cat here. And if instead I had you make a concept for an apple, which had a leaf and a stem, you might be able to see this image as an apple with a leaf and a stem. So in each case, your brain is using past experience to construct a concept to make sense of these lines so that your brain knows what to do next. Do you pet this thing or do you eat it? And the same is true for emotion categories. So is a smile in someone else's face, is it an example of expressing happiness, of expressing dominance, of expressing affiliation, of expressing anger? It depends on what your brain guesses that smile to mean in that situation based on your past experience. So it's conjuring a concept to make sense of the sense data, including that smile. Now I'm going to stop here because the next thing that I'm going to do is kind of walk you through this step by step, because it's actually, I'm looking at the time, but I think we have time for this because I think it's really important that you understand exactly how this works, because it will, I think, be helpful to answer the question of what's really happening under the hood. If your brain isn't being hijacked by your amygdala, what is exactly happening? So, but before I launch into this, maybe I'll stop and see if there are any questions that
So Lisa, there's 112, and I'm just going to say for most of them, I really recommend that you read both of Lisa's books, because there's a lot there. I think the thing that's coming across as one theme that maybe you can close on is like, what the heck do I do next with my own emotions? What does it mean to be emotional intelligence in this context?
Yep. So I think what I'd like to do is just walk you through what scientists' best understanding is of what's happening in your brain, and then I think it will become clear what's advisable in terms of what to do. So this is going to sound a little academic, but there's really no way around it, really, to give you the level of precision in what I'm about to say. So I have a series of slides with lots of fancy, images, and but I want to make sure that I actually get the information across, and so I'm gonna go with the boring slide instead of the beautiful fancy animations. So if we were to stop time right now, we could take stock of what's happening in your brain. And if we were to stop time right now, your brain would be representing what it believes is happening in your body and in your brain, and then making a prediction. It's reconstructing memories. So memories are not, things that you recall. They're not really things that you retrieve. They're not stored in your brain in any way. Your brain is basically re-implementing them or reassembling them as you need without your awareness. This is really how memory works. And it's making a set of predictions about what to do in your body. Should your heart rate go up or should it go down? Should your breathing increase or should it decrease? Should you release cortisol because you need glucose in your blood quickly or not? So it's preparing changes in your body, which I refer to as body budgeting. That is budgeting glucose and salt and water and so on. And the technical term for this is called allostasis. It's also preparing your actions. Are you going to run? Are you going to sit quietly? Are you going to smile? And so on. This is the first thing your brain does when it's making a prediction. It prepares a set of actions. And based on those actions, it asks itself, the last time I did this, what did I hear? What did I see? What did I smell? What did I feel? So it's preparing a set of experiences. And all of this is a concept. That's what a concept is. So a concept, it is a tool for regulating your body and for planning action. And as a consequence of that planning, a concept is also the preparation of experience, to experience the world in a particular way. And then there really is information coming from your body and from the world, sense data from the body and from the world. And when those data match the prediction, then you experience what your brain prepared you to experience, and the actions are released, and you act in the way that your brain planned for you to act. And off you are onto the next state. And this is what we call automatic processing. It's, or what we think of as system 1 processing. Sometimes, though, the brain predicts poorly. It doesn't predict something that it should have, or maybe it predicts something that doesn't happen. And this is an opportunity for the brain to learn. So this is the circumstance where your amygdala will be very, very active, telling the rest of the brain, learn, 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 and code this new information so that I can predict differently the next time better. And this changes the memories that are reconstructed in the moment. It changes the action plan and the plan for what's going on inside your body. And it changes the way, the experience that your brain prepares you to have. And this is what we refer to as controlled processing, where something in the world has changed what's going on inside your head and the plans and preparations that your brain has made. So the important thing to realize here is that a concept isn't an abstract thing. It's actually a guide to your actions that predictively, it predictively guides what your brain is preparing your body to do, both inside your body and actions. And so the one answer here to what you should be doing differently is creating experiences for your clients that seed their brain to predict flexibly. Because the more your clients learn varied experiences, the more they have varied experiences, the more opportunity they have to learn to predict differently in the future. You know, in a sense, the things that you experience today become the past that your brain uses in order to predict differently tomorrow. So in a sense, you're always cultivating your past as a means of controlling who you will be in the future. So one thing your brain can do is, one thing that you can do with your clients is you can teach them to predict differently. Now, cultivating experiences in the moment is a little bit like exercising in the moment. It's really hard. It's not always pleasant, but it's a really great investment of your time and energy. And partly the way that you do this is by practicing. It's just like driving. You know, if you practice something, at first it's hard, it takes a lot of effort, but then eventually it gets to be very automatic. So if you want your clients to be resilient in the future, you have to help them train their brains to predict fluidly and flexibly in various situations. And that requires a variety of experiences that get wired into the brain. Another thing that you can do to help the brain predict flexibly is to change, change the way that the world is experienced. And what I mean by that is, if I want my brain to predict differently, I can just get up and move to a different room or go outside. If I change my context, remember, the current state is what your brain believes is going on in the world and in your body at time zero, right? At like ground zero, like right now. So if you want your brain to predict differently in the next moment, you just change the context, and then your brain, or change the state of your body, get up, move around, go for a walk, and that will change the flow of predictions usually. Sometimes we can't get up and go for a walk, so you can be mindful and you can pay attention to things in right around you differently, and that actually, in effect, in a figuratively, changes your the flow of your predictions. So the answer here is, if you want to be a flexible predictor, you want to encourage your clients to have what's called emotional granularity. And that is to have a large vocabulary of emotion words, emotion knowledge, that allows the brain to have a larger, more flexible repertoire of emotional events that it can make and perceive in others in particular situations. And this is one aspect of emotional intelligence. It means that your brain, a brain that is emotionally granular, is a brain that can make any number of predictions and regulate action and experience in very, very flexible ways, in ways that allow people to actually cope better with the immediate situations. That's what the research shows. Actually, research shows that people who are more emotionally granular not only actually cope better with situations, they're actually physically healthier, they recover faster from illness, and so on. And that's because, as I said, concepts are tools for regulating your body. They're tools for regulating the inner systems of your body, and they're tools for regulating your action. So before I go on to the next fiction, assuming we have time for that, I'll stop and take questions.
So thank you. I think, Lisa, everybody's in awe just of the magnitude of this work. And I maybe it would be helpful to just ask a clarifying question in the hopes that I'm not the only one seeking this to be clarified, which this idea of fluid and flexible, is that akin to detaching from one's own predictions and the messages of one's own emotions to a more flow-like state with the experience, so that you're actually more in learning mode than predicting mode? I'm just trying to get at like the experience of being human. Is that where we're going here?
Yeah, that's certainly one. I would say that's one extreme of where you could go. So if you think about everything that you experience and everything that you do is some combination of what's in your head and what's outside your head, meaning what's in your body and what's in the world. Because from your brain's perspective, it actually doesn't know where your body ends and the world begins. It's constantly estimating that, actually. So from your brain's perspective, everything you do and everything you feel and experience is some combination of what's in here from past experience and what's out here in terms of the present. Now, one mode is when you're predicting really automatically and your predictions match reasonably well with what's going on in the world. You have to you, it feels like stuff's just happening. You have no sense of agency. You have no sense of control. To you, it just feels like everything's happening very automatically, like you're on autopilot. And to some extent, you are on autopilot. And these are situations where the information from the world and from your body, its only function in these cases is to verify the prediction. That's it. No information, in addition, makes its way into your brain, because your brain's already firing in a way that matches the prediction. I mean, that matches the sense data. When your brain makes a prediction, I'm not sure I'm going to have time to get to the this illustration, but When your brain makes a prediction, it's not some abstract prediction. It's changing the firing of your own of your neurons. Your brain is changing the firing of its own neurons to prepare you to hear something, to see something, to smell something, to feel something. And when the sense data come in and verify those predictions, the brain is already firing in a way that is ready to construct your experience and control your actions. And so poof, it happens. But if you want to change your predictions, either in the moment, which is hard, or change your predictions now, that is, learn something different now so that you can predict automatically differently in the future, then you have to find a way to turn down the dial on the prediction and turn up the dial on learning. And that does mean getting outside of your own head to pay attention to what's in your body or what's in the world. And mindfulness is one way of doing that. It's not the only way of doing that, but it certainly is one way to learn to basically seed your brain with different opportunities for predicting in the future. Another is to invest effort to very willfully construct new experiences in the moment. So for example, in a difficult conversation with someone where you can feel yourself starting to get worked up, you could use that as a cue to stop and be curious. I like the contemplative saying, anger is a form of ignorance. Anger is a form of ignorance because it means you're ignorant. If you're angry, it means you're ignorant of the other person's perspective. And I use that as a cue whenever I find myself getting angry. My brain is constructing anger, but I can grab a hold of that, and I can grab a hold of that to be curious, and it can stop me from completing that prediction and lead me to be foraging for new information. So I'm constructing curiosity, I'm constructing wonder, I'm constructing a different kind of experience for myself that will teach my brain something new that it didn't know, in hopes that that's kind of an investment for the future, so my brain will predict differently. Or, I practice making an experience of awe every day for 5 minutes. And this is, it's like a deliberate investment of energy that I make, and I practice it. And this seeds my brain to be able to make awe and wonder much more automatically in the future. Like driving. If you practice it, it's a skill. Or learning emotion concepts from other languages, or exposing yourself to other people's perspectives and learning from them what it feels like for them to be in the world the way they are. These are experiences that seed your brain, if you practice, seed your brain to automatically predict differently in the future. Trying to change your predictions in the moment is hard. It takes energy, and it's often unpleasant. But it's just like exercise, which is also hard and it requires energy and can sometimes be unpleasant. It's an investment in allowing your brain to be healthy and do something more easily in the future.
You're working the positive side. Good. So I know there's only a few minutes, and if you can weave into the end, I think people would love to be reminded what the 3 myths were.
Yeah.
So a definition of emotion after all that said.
Yeah, well, a definition of emotion is your brain making sense of your body in relation to what's going on around you in the world. That's the definition of emotion. And it's not a definition that's different from a definition of what a thought is or what a perception is. That's the essence of this approach. I guess I have to turn back on sharing. So I'll just go through this as quickly as I can. So emotional granularity. The first lesson was that when it comes to expressions of emotion, variation is the norm. And your brain, when you perceive emotion in others, is really guessing. the guesses really are predictions. The second is that emotion and reason are not living in separate parts of your brain. Your brain is not a battleground for emotion. Your amygdala doesn't hijack your brain in any way and cause you to do bad things. Instead, your brain is constructing emotion. It's making emotion as you need it by doing what it always does, which is using past experience predictively to make sense of your body in the world so that you know what to do next to keep yourself alive and well. And the third myth is that your body is unimportant for emotion, is important for emotion, but it's unimportant for thinking. And this is a myth because, as we've seen, all concepts, even the concept of a cat, has implications for your body. Because every concept that your brain makes as a set of predictions starts with predicting what needs to happen inside your body in order for you to be able to move and deal with the situation at hand, right? Do you need to eat the apple or do you need to pet the cat? And what you experience in the world is a consequence of that. This is something that physiologists and neuroscientists know. They understand that brains evolved and are structured to regulate your internal milieu. That means the systems of your body, to anticipate the needs of those systems and to prepare to satisfy them before they arise. So what this means is that metabolism and energy regulation are at the core of everything you do. Everything you do. You have no awareness of this, that every thought and feeling that you have has something to do with your metabolic state, but it does. And that's an important thing to know. Your brain didn't evolve to think or feel or see. It evolved to control your body. And your brain thinks and feels and sees in the service of controlling your body. Your brain's business is budgeting, as I said before, the internal resources of your body, like water, salt, glucose, and hormones to keep you alive and well, so that you can do, your most important job from your brain's perspective, which is to pass your genes on to the next generation. And this continuing budgeting process is invisible to you. It goes on all the time from the moment that you're born until the moment that you die. And all of this body budgeting produces a symphony of sensations which you are largely unaware of because you are not wired to experience them. And so instead, evolution has given you a workaround that hints when your body budget is generally imbalanced and when it's in the red. And this is what people call mood, or what scientists like me call affect. These are the physical feelings of comfort and discomfort, of calmness and agitation. These affective feelings are always with you in every waking moment of your life, whether you're emotional or not, whether you're aware of them or not. This is like a quick summary of what's going on in your body budget, like a barometer, without much detail. And your brain has to link these simple feelings to what is going on around you in the world in order to know what to do about them. And the result is sometimes, but not always, an emotion. And this is how an ache in your stomach can be anxiety in one situation, and it can be hunger in another situation, and it can be a gut feeling about somebody's guilt in yet another situation. So your body is a part of your mind, and this is not an airy-fairy, mystical, metaphysical statement. This is a very, very basic biological statement that I'm giving you. Now, unfortunately, we're completely out of time, and so I guess I just show you one more slide and then I'll stop, because I really, really want you to experience this. I think it's really important. So most people, when they're looking at this, know instantly what it is. It's an electrical tower playing jump rope. How do you understand what you're seeing? because no one ever in their whole in real life, has ever seen an electrical tower jumping rope. And the truth is because your brain is making a concept. It's remembering bits and pieces of past experience and combining them in a novel way to create a prediction about what this means. And so, you know, this is called conceptual combination. It's something that your brain does very easily. But how many of you can actually hear the thud of the tower hitting the ground? And how many of you can actually feel the pounding in your chest? This is what neuroscientists call a controlled hallucination. But it's not the kind of hallucination that would lead you to run to the hospital, because what your brain is doing here is exactly the same thing as it does when it makes a prediction. It's creating a concept, which is a prediction. Based on what you see, your brain is expecting what you will hear and what you will feel. And it's changing the firing of your own neurons to prepare that experience for you. So this is what it means to say that your brain is constructing a concept. This is what it means to say that concepts are a way of controlling or regulating your body, and as a consequence, your experience. That your brain has this amazing capacity to change the firing of its own neurons to construct your experience. If you want to learn more about these ideas, you can certainly have a look at my first book, How Emotions Are Made, The Secret Life of the Brain, and my second book, 7.5 Lessons About the Brain. And I have many talks and articles and so on my website. And I will thank you for your patience and your patience today.